Okay guys, here is our latest video based on the topic that we're doing at the minute. It's all about counting. So first things first, we need to look at all of our keywords. We've 5 in total: sample space, systematic listing, two-way table, tree diagram, and fundamental principle of counting. As we go through the definition of each piece, it will pop up. So the first definition we look at is the idea of a sample space, and a sample space is defined as the list or set of all the possible outcomes. So for example, if a runner, in this case we've looked at our Irish sprinter Thomas Barr, if he is competing in any race, he has the possibility of winning a gold, silver or bronze medal. So we would say our sample space is gold, silver or bronze. Same way if we were to say, if you were rolling a dice, what would be our sample space? 1, 2, 3, 4, 5, 6. Notice as well that when you're listing your sample spaces, you have to include the curly brackets like we used when we were doing sets. Okay, so our next definition that we meet is how we list them all together, or something called systematic listing. And that's where we write all of the possible outcomes down, but we put an order on them. So if you were to give me the list of numbers from 1 to 10, you would start off at 1 and you'd end up at 10, and listing all the numbers in between and including your curly brackets. Similarly, if you were to give me the months of the year, you'd start with January and you'd end with December. You'd list them in the middle and your curly brackets would be at the end. It can be done for loads of things, but there is an unfortunate disadvantage to this, in that it can be quite long. So one way to combat this is to come up with our second idea, and our third keyword that we're meeting here today is something called a two-way table. So a two-way table, if there are as many possible outcomes, listing them can be really hard, and a two-way table is a convenient way of showing all the outcomes. So the example I'm going to use is the idea if you were tossing a coin and throwing a dice at the same time. Now, throwing a coin might seem easy. You've only 2 outcomes. It can either be heads or tails, but you can have 6 different outcomes with your dice. So very quickly, this can get very messy and it can get very confusing if we had to list them all. We use a table to help us figure them out. So when you're drawing your table, it's really important that you guys use a ruler and that you make sure they're nice and straight. If you use a pencil as well, that's going to help. So when you're drawing your table, you have to remember the 2 factors you're including. We're including our heads and we're including the different numbers on the dice. I'm going to put my heads and my tails over on the left hand side, and I'm going to put my numbers going down on the columns up at the top. Make sure you have them counted right as you're going through. Hopefully that's enough. So heads, tails, 1, 2, 3, 4, 5 and 6. Now what we need to do is we need to match up each row and each column. So in the first one here, it matches heads with the number 1 on the dice. If we keep going all the way across, I match the heads with the number 2, the number 3, number 4, number 5 and number 6. At the very bottom then it switches to tails. So tails now is matching with number 1, then number 2, number 3, number 4, number 5 and number 6. Much easier than listing them all out, and straight away we can see from each of our lists that we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 outcomes in total. The next way we have of representing information is something called a tree diagram. Not to be confused with a stem and leaf diagram that you'd use in statistics, but very similar because it looks like a tree at the end result. So if we have a look at some examples, you'll see what I mean. So the trick with tree diagrams is to make sure you leave them nice and big and you give yourself plenty of room. So the first example I'm going to look at is the idea of a menu in a restaurant. So in a restaurant, you might have a choice of some starters, some main courses and dessert. For example, let's just imagine we have soup for a starter and we might have some chicken wings. We, following on from that, could have 3 choices for dinner. We could have lasagna, we could have chicken, or we could have beef. I could still have those 3 choices with my chicken wings: lasagna, chicken, or beef. And following on from each of those, I might have 2 choices for dessert. I might have a chocolate brownie, or I might have some ice cream. So each of those gets their 2 choices of dessert as well. So straight away, you can see why it's really important that we make them nice and big and nice and clear. You guys will be using a ruler as well to help you, and don't be afraid to use them because it keeps the information very neat and easy to follow. So straight away we can see there is an awful lot of possibilities. I had 2 starters, 3 main courses and 2 desserts. In total, if we count up, we could have... So if we count up our options now, this could take a while, but it will be worth it. And we use a different colour pen. So there is option 1, option 2, option 3, and option 4. Option 5, option 6, option 7, option 8, option 9, option 10, option 11, and option 12. So in total, you have 12 choices to choose from the whole entire menu. Writing it out this way saves an awful lot of time, and it becomes much, much clearer when you have it drawn out nicely than your two-way table. So our final keyword of this chapter is the idea of the fundamental principle of counting. So this is a little formula that we have. So if one event has n possible outcomes and a second event has n possible outcomes, then the total number of outcomes is equal to the n multiplied by the n. Let's put that into context. In this example, we've 3 coloured t-shirts to wear. So we have black, red and white. With 2 choices of trousers, we have blue and we have black. If we think about it, we have 3 choices for our t-shirts and we have 2 choices for our trousers. So 3 multiplied by 2 gives me a total of 6 choices. That's much, much easier. That's much easier than the idea of our two-way table that I have drawn out here. And if you look, it still gives us the same answers. We can count it up. Option 1, 2, 3, 4, 5, 6. But simply just going 3 by 2 is an awful lot easier. That's the end of that video on that particular chapter. I hope it was helpful. See you later.